Okay, 8.5, we are going to do area between the curves again, but now we're going to consider doing it with respect to y instead of with respect to x as we've been doing. Okay, this problem we did in the last section. Remember, we had to do the integral from 0 to 6 because this was the upper and this was the lower function. And then we went from 6 to 9, we did this and this. Okay, now if we look at this from the perspective of y, we can also solve it. And sometimes it's an easier setup, sometimes it's not. Okay, so let me think about this for a second. Okay, so I'm kind of looking at it sideways. I want to do in the y direction, so I'm gonna go from here to here. Okay, so stand and stare at it from this direction. If I'm standing from this y-axis right here, this is the top of my curve, and this is the bottom of my curve. Okay, so if this is the top of my curve, I'm going to do that minus this other function, which is the bottom of my curve. However, because I'm doing this with respect to y, I need to change my equations so that they're in terms of y. Okay, so let's see which one's which. Okay, so let's see. This is going to be my higher function. We wrote it as y equals x minus 6. If I want to do the integral with respect to y, I need to solve this for x, so it will be in terms of y. So I'm going to add the 6 over. I get x equals y plus 6. This is my higher function. Minus. Okay, now let me look at my lower function. My lower function is this one. Okay, what is that? That's y equals root x. Since I'm doing the derivative with respect to y, I want to solve for x, so it's in terms of y. So if I square both sides, I get x equals y squared. Okay, so this is going to be y plus 6, and then my lower function, my lower curve is y squared. I'm going to do this derivative with respect to y. Okay, now let me think about my boundaries. Okay, I'm looking at it sideways. I'm coming from the y-axis, upper function minus lower curve. Okay, this is the distance on the y-axis that the curve covers. It goes from y equals 0 until y equals 3. So I'm going to do this from 0 to 3. Okay, now if we solve for the area, we should get the same answer that we got in the last class. I'm going to go ahead and put this in my calculator, but we could do this by hand as well if we wanted to. Your calculator only knows x, remember? So when I do math 9, I'm going to put an x here and an x here and an x here, but the result is going to give me the correct result. Okay, I got 13.5 square units. Okay, and remember we did do this yesterday with respect to x, and we had to break it from 0 to 6 to 6 to 9, which in the y direction I only had to go from 0 to 3, so sometimes looking at it in the y direction makes it an easier problem. So you should look for it both ways to see which way is easier. Okay, let's go ahead and consider the next one. Example 2 says set up the integral. Oh, actually example 1 didn't say to solve it, but I did. Okay, we're just going to set up the integral then. Okay, example 2 says set up the integral to find the area bounded by x equals 3 minus y squared and x equals y plus 1. Okay, well, since these equations are solved for x already, I'm thinking I'm going to do it in terms of y. Okay, now if I thought maybe I wanted to do it in terms of x, if I were to do that, I would have to start x equals -1. Then at x equals 2, I would have to stop it because this curve and this curve are consistent. And then when I get here, it's like the same curve twice. Okay, so I'm going to look at it from the y direction. Okay, area equals. Okay, if I'm looking at it from the y perspective, I'm going to stand on my y-axis and I'm going to look towards the positive x-axis. If I'm standing here, this looks like the higher function. The one further to the right is the higher function. Which one is that one? It must be x equals 3 minus y squared because it's like a sideways parabola. Okay, and this is already in terms of y, which makes it easier. Okay, the lower curve is this one, or the further to the left, and that's x equals y plus 1. And I'm doing this in terms of y, dy. Okay, now in the y direction, I want to see when I need to start measuring the curve. Okay, so on the y-axis for this curve right here, y equals -2, and I'm going to measure this all the way until I get to here, which is y equals 1. So I'm going to do the area under the curve from -2 to 1. Okay, I'm going to rewrite this in standard form. You don't have to. And then we could evaluate it by hand, or we could do it ourselves. What is that? That's -y² minus y. 3 minus 1 is +2. Okay, but it just says to set it up, so I'm going to stop there. Okay, last example, but we're going to do it 2 ways. Okay, they've given me 3 functions. They're graphed here. The area between their curves is this region in here. Okay, I'm going to do this once, setting up the integral with respect to x, and then the second time I'm going to do it with respect to y. And I'm not going to solve it, but I am going to set it up. If I actually did solve it, I would get the same results both ways. If you can do it both ways, though, you can normally optimize and see which one's going to be the easiest way. Okay, this is going to be, okay, let me just label my functions first so I can keep track of which is which. So 2 minus x² is this parabola like this. I'm going to label it just so when I'm staring at this, I can find it. Okay, and then I have y equals x minus 1². That's a parabola, move to the right one. That's that one. And then the last one is y equals 3/2 x plus 1, which is a line. Okay, they're all solved for y and in terms of x, which is good because I'm going to set up the integral in terms of x. Okay. A equals. Okay, now I need to think because there's a bunch of pieces I'm going to consider. Let's start on the left and figure out the first piece. Okay, what do I start with? I start right here. What is this point? This point is 0, 1. So I'm going to start at x equals 0. Okay, at that point, or a little bit to the right of the point, this is my higher function, the 3/2 x plus 1. Okay, and then my lower function is this equation right here, which is this one right here. Okay, and I'm doing this with respect to x. Okay, now this is the upper function, this is the lower function. This ceases to be true when I get to this point right here. So that area is only going to work from here to here. So for this piece right here. After I leave that, once I hit this corner, things are going to change. So I need to figure out the x value here. Okay, since this is a calculator question, I'm going to graph y equals 2 minus x² and y equals 3/2 x plus 1, and I'm going to see where they intersect on my calculator. So graph, I'm going to do second calc, and let's see what value we get. Okay, so I got 0.5, 1.75. I really only care about the x right now, but because I'm going to do it with respect to y in a second, I'm going to go ahead and label both. So that is only true from 0 to 0.5. Okay, but there is more area, so let's add on another piece to this little puzzle here. Plus. Okay, my next integral is going to start from x equals 0.5. Okay, at this point, now this is the upper function, which is the 2 minus x². The lower function is going to be this function, which is the x minus 1². Okay, and I'm still doing this with respect to x, and that's going to give me from here to here. Now the question is, where is here? Okay, I need to figure out where this graph intersects with this graph. So we're gonna, I'm gonna graph them and see where they intersect. You could try to do it algebraically as well, but since it's a calculator active problem, I know decimals are allowed. Okay, graph it, and then do your second calc intersection to see where they intersect. Okay, I got 1.366. I'm gonna keep a couple extra decimals. If I were actually evaluating this, these decimals would be very important and I would probably store them. But since we're just doing the setup, I'll leave it like this. Okay, I only need the x coordinate, but I do know in the second part I'm gonna need both, so let me go ahead and label both. Okay, now do we hit everything? So we started from 0 to 0.5 and we got this part of the area between the curves. And then from x equals 0.5 to x equals 1.36602, we got the area under this curve, and then we're adding them together, and that's the setup for our integral for the areas. Okay. Now if I put it in my calculator, I get a nice answer, but I don't want to. Okay, so part B, we're gonna do the same equations, same everything, except now we're gonna do it with respect to y. Okay, let me relabel my equations and stuff. Okay, part B, let's set it up with respect to y. I just labeled the intersection points and I put the same equations there, although I don't want the same equations. Since I'm gonna do it with respect to y, I want these equations in terms of y, which means I need to solve for x. Okay, let me solve for x real quick. What's this gonna be? This is gonna be x squared equals 2 minus y, and if I square root it, I get x equals, actually the plus or minus square root of 2 minus y. But let me look at this real quick. Let's see, but this graph, the area of the curve I want is only in quadrant 1, which means I only care about the positive square root of 2 minus 1. Why? If the x was negative, I would put the negative, but because we're in quadrant 1, the x is positive. Okay, let me go ahead and solve, let me box this so I don't lose it. The y equals x minus 1 squared. Okay, so I'm gonna square root x minus 1 equals plus or minus root y. Okay, so I got x equals 1 plus or minus the square root of y. Okay, what does that mean? What graph are we on? We're on this one right here. So this is x equals 1. When I plus root y, I'm on the right side. When I minus root y, I'm on the left side. So even though it's weird, let me erase this. I'm gonna label each half separately. When I'm on this side, it's x equals 1 plus square root y. But if I'm on this side of the vertex, it's x equals 1 minus root y. And this is the vertex right here. Okay, what is the other one? The line. I'm gonna minus the 1. So 3 halves x equals y minus 1. I'm gonna times by 2/3. 2/3 y minus 2/3. Okay, now let's try it. Area equals, okay, on the y-axis, so this way. The lowest y value it starts from is right here. This is y equals 0. What is this point? This is 1, 0. So 0, when we start here, oh, it's a tiny little function. Okay, this little piece of sliver of area right here. See that? Okay, the upper function is this. What is that? That's the 1 plus root y. Minus, okay, that's my upper. Right here, my lower function is the 1 minus root y. So it's good we split that off. Oops. Okay, and I'm doing this with respect to y, so I'm gonna put the dy. Okay, now that tiny sliver of area ends when I get to y equals right here. The y value here is the 0.13397. Okay, and I'm keeping it, if I were actually evaluating it, I would probably store it. If not, I would keep a ton of decimals on it to be safe. Okay, now let's go to the next piece. The next piece of this integral is gonna start at the 0.13397. Okay, so now I'm over here. Okay, the higher curve is gonna be here, that little piece. Let's look at this. Okay, what's the lower curve? The lower curve is this thing until I get to this point right here. So that's gonna get cut off right here. Okay, so this is from 0.13397 until right here, the y value is 1. So let me put that boundary in. Okay, now for this little region here, the higher curve is this. What is this? This is this in terms of y. Minus the lower curve, or the further left curve, is this one. This is this. 1 minus root y. And I'm doing this with respect to y, so dy. Okay, am I done? No, I still have another piece. Okay, last little piece. Okay, so one more piece. What is it going to start from? It's going to start from y equals 1, because that's where I left off. Okay, at y equals 1, the upper curve is this thing. What is that thing? This curve is still the root 2 minus y. Minus the lower curve is this line right here, which in terms of x was the 2/3 y minus 2/3. And I'm doing this with respect to y. Okay, so I went from y equals 1, and then here the y value is 1.75. Okay, and then that's this region right here. So I got this tiny little piece at the bottom, and that was from y equals 0 to 0.13397. And then from y equals this to y equals 1, that was this. And then from y equals 1 to y equals 1.75, I got this. So I got all the pieces of the area, and it should give me the same result if I had done it with respect to x.